I'm William San Martin. I'm an assistant teaching professor of global history in the Humanities and Arts department. Climate change has renewed our concerns about socio-political dimensions of food production. From a policy perspective, however, it is also critical to understand the degree to which farming practices, sciences, technologies, and politics have historically shaped global-scale ecological change. As environmental scholars argue that major innovations in how we eat and farm are needed, historians are challenged to develop novel approaches that can inform decision makers and the general public. I'm a global historian and a science and technology studies scholar. My work focuses on understanding how knowledge and technologies regarding socio-ecological issues are created, circulated, and contested across disciplines, institutions, and national borders. And in my talk today, I'm going to share with you the experience of a South American nation, Chile, with what is considered a major global ecological concern, nitrogen. And I'm going to argue that this experience, although similar to other cases in other nations, can provide a model for the study of science, policy, and the global struggle for environmental sustainability. So let's start talking about nitrogen. Nitrogen is mostly present on Earth in unreactive forms. That means it is chemically unavailable to most living organisms and must be fixed into a reactive form before animals and plants can use it. Scientific knowledge on the nitrogen cycle has significantly increased since the 1950s. Today, we have a better understanding on the many human sources of nitrogen and its multiple ecological effects. Scientists even predict increasing rates of reactive nitrogen during the following decades, especially in places like Latin America, Asia, and Africa. So, within this long history of human nitrogen fixation, the widespread use of fertilizers during the second half of the 20th century, within has been called the Green Revolution, has been depicted as one of the main drivers increasing reactive nitrogen globally. Scientists have lately developed the concept of the nitrogen cascade to describe how a single atom of reactive nitrogen causes a number of ecological effects across time and space. This concept is a turning point in the history of global nitrogen science. It highlights how nitrogen release in one particular place creates a cascade effect across aquatic, terrestrial, and atmospheric ecosystems. Although the nitrogen challenge has had limited public attention compared to biodiversity loss or climate change, scientists agree that nitrogen will be considered the carbon of the 21st century and one of the most silent human drivers of global environmental change. So, how can history offer novel approaches to the nitrogen challenge? Let's go back to Chile. What is particular about this case, besides it's a beautiful country, of course? Chile is one of the highest consumers of nitrogen fertilizers per hectare in the Americas, and it was already during the early 1970s. Chile is considered one of the cautionary tales on the effects of neoliberal policies in the environment. And Chile illustrates one of the major problems we have today in environmental policy. It shows how scientific knowledge is not enough. The green area you see there is Chile's main agricultural land, the area where most of the fruit that we consume here comes from, and the area where most nitrogen is used. So how do we get to this point? Between the 1950s and the early 1970s, Chile massively increased fertilizer consumption in this area. This was a product of a particular model to accelerate technological change. The Chilean state, with the support of local universities and international experts, established a model of multi-agency cooperation. This model expanded the role of experts in policy-making agencies and an institutional network that connected scientists, technicians, and farmers in an unprecedented way. As a product of these programs, nitrogen consumption increased more than 700% in less than 20%. This is what I call Chile's nitrogen revolution. Although this model caused several social and environmental effects, it was highly effective in accelerating technological change and changing farming practices. After 1973, when a military coup took place in Chile, this institutional framework was destroyed. State support for agricultural research was reduced, Agricultural experts were displaced from policy-making agencies. Doesn't sound familiar, maybe? Scientists were isolated in universities and research institutions with limited power to influence farming practices and policies. When Chile got back to democracy in the 1990s, scientists had a better understanding of the broader effects of nitrogen. However, the institutional network connecting experts, farmers, and policymakers had been dismantled. I argue, first, that in order to face the nitrogen challenge at a local scale, Chile requires to build or rebuild this infrastructure for science policy interface. And second, assessing the histories of science and policy at a local and regional scale will be critical to address the global nitrogen challenge. Today, we hear more and more often about the lack of science-based policy. My invitation is to think about a deeper history of the role of experts in decision-making processes and the role of local science and institutions in global environmental change. Thank you.